Hello everyone, in previous lecture we have discussed Stille coupling reaction, and before that Stille coupling reaction we have discussed Hake reaction. Now in today's lecture we have to discuss a Sonogashira coupling reaction or Sonogashira reaction. In this Sonogashira reaction or Sonogashira coupling, there is a copper and palladium metals are involved. In Stille coupling, palladium plus tin metal are involved. In this Sonogashira coupling, copper and palladiums are involved. Copper iodide mostly used in this reaction, which is used as a co-catalyst. Copper iodide as a co-catalyst used or involved in this Sonogashira coupling reaction. This Sonogashira coupling reaction is copper palladium catalyzed coupling reaction of terminal alkynes. Here one reactant is terminal alkynes with aryl or phenyl halides. Sometimes in some reactions there is alkyl halides are also involved with aryl or phenyl halides to give enines. To give enines means substituted carbon-carbon triple bond. Okay, is referred as Sonogashira reaction. Definition of this reaction for copper as well as palladium catalyzed coupling, reaction between terminal alkynes with aryl or phenyl halides to get enines means carbon-carbon triple bond substituted, means enines are there, is referred as Sonogashira coupling reaction. Now here in this reaction this one is stereospecific reaction related to this aryl or phenyl halides. Here different halogens are involved, that is like chlorine, bromine, iodine and triplet. Here with respect to that halogens, here stereospecificity is there. Iodine is more reactive than triplet. Selectivity related to this halide are iodine is more reactive than triplet, which is more reactive than bromine, which is more reactive than chlorine. This one is selectivity related to this or stereospecificity related to this phenyl or aryl halide. This one is stereospecific reaction with respect to that reactant aryl or phenyl halides. Okay. Then copper iodide acts as a co-catalyst in this reaction. Now general reaction for this Sonogashira coupling. General reaction for this Sonogashira coupling: alkyl halide plus alkynes. Here alkyl halide plus alkyne are there. Here R2, but here palladium 0 or palladium second as a used or involved as a catalyst, with copper iodide as a co-catalyst and salt or base are also involved, and we get a enines or a couple product. Here in this reaction or in previous two reactions we used only palladium in zero oxidation state catalyst. Here we directly use palladium zero oxidation state, means palladium catalyst in which palladiums in zero oxidation state, as well as catalyst in which palladium in second oxidation state. Such a catalyst are involved in this Sonogashira coupling reaction. Here R1, R2 are alkyl, aryl, acyl, heteroaryl, like that. Here halogens or X group may be iodine, bromine, chlorine or triplet. Okay, some bases are used in this reaction. That bases are amine bases. For example, NHET twice, this one is also example of amine base. And solvent used in this reaction mostly THF, ETOAC and methyl cyanide. These are the solvent which is used in this Sonogashira coupling reaction. No need to remember this one, but this one you have to remember related to our general reaction. Alkyl halide coupled with alkynes with palladium zero or palladium second oxidation state catalyst, we get a coupled product, that is enions. Okay, this one is related to general reaction of Sonogashira coupling. Next one, catalytic cycle. Catalytic cycle related to this Sonogashira coupling. Here same, here they will same like oxidative addition, transmetallation, reductive elimination, these three steps same like to Stille coupling, but here another one or additional reaction is there which is related to our co-catalyst copper iodide. First, our alkyne reacts with amine base plus copper iodide as a, here we wrote copper X is copper iodide is there. We get product like this, that copper metal attached to that alkyne, and that will be involved in transmetallation step. Now our catalytic cycle related to this palladium catalyst. Sometimes here second oxidation state that will be increased to 4. Okay, first one, palladium as a catalyst shows oxidative addition. This palladium shows oxidative addition R1X, that is alkyl or mostly aryl or phenyl halide are used. Oxidative addition of alkyl or phenyl halide, we get palladium attached with halogen and our aryl or phenyl group, that is R1, and with ligands. The next step is transmetallation step. Next one is transmetallation. Transmetallation step is there, in which copper attached with alkyne, copper attached with our alkyne group. From this this one is our alkyl group or alkyne group, that will be transferred from copper to palladium in this transmetallation step, and copper will be eliminated with our this halogen. means here palladium attached with alkyne group and first R1 group and ligand as it is, and in last step there is reductive elimination. There is reductive elimination will be takes place and we get a coupled product R1 coupled with R2. There is formation of enines is there. This one is reductive elimination step. First oxidative addition, palladium shows oxidative addition to alkyl halide. After that transmetallation of copper and palladium metal, and then last one is reductive elimination. This one is simple mechanism or catalytic cycle for Sonogashira coupling reactions. Okay. Now next part related to this reaction is our examples. Next one is examples. Okay, here in some books here catalytic cycle will be continue here, like here copper, this copper halide plus alkyne our starting material. Okay, this will be react and we get HX with respect to our amine base. Here we side product is HX, that will be also given in some reference book. Okay, then next part to this reaction is our examples. Examples related to this Sonogashira coupling. Here we use one equivalent of alkyne C5H in presence of palladium catalyst, triphenyl phosphine as ligand, and copper iodide as a co-catalyst, and amine base are also involved in there. Okay, we get a coupled product. Here we use one equivalent only, so we get product like this C5H11, and here one chlorine remains as it is. There is new bond formation takes place in between these two carbon, means this carbon and this carbon, in between these two carbon there is a formation of new bond. Okay, here chlorine will be get depart, or here oxidative addition is takes place. After that here side by side here like that, here copper will be replaced by this hydrogen, and here this copper compound, here this one is palladium. Then second step transmetallation will be takes place, and after reductive elimination we get this coupled product. This one is our example first. Like that example seconds are there. Here cis compound is there, we getting a cis product. If trans compound is there, same condition are there, means same alkyne palladium copper, same conditions are there. We get a same trans product, means no change in stereochemistry are involved in this coupling reactions. In every coupling reaction there is no change in stereochemistry. Okay, if we use two equivalent, we get both alkyne group attached to that carbon. Okay, another one example related to this Sonogashira coupling. Here simply iodobenzene reacts with in presence of palladium catalyst and copper iodide as a co-catalyst, and here DMF as a solvent, we get a product like this. And here R group remains as it is with their position. Okay. Now another one example related to this, here 1,2 disubstituted iodobenzene is there. Same condition is there, product will be like this. Okay. So this one is examples related to our Sonogashira coupling reaction. We discuss in this Sonogashira coupling, first one definition, terminal alkynes, this one is copper palladium catalyzed coupling reaction of terminal alkynes with aryl or phenyl halides to get enenes is referred as Sonogashira coupling reaction. Then we discuss general reaction to this Sonogashira coupling reaction. After that we discuss catalytic cycle, and after that we discuss examples related to this Sonogashira coupling reaction. Okay. So this one is discussion related to our Sonogashira coupling. Next reaction will be discussed in next lecture. Thank you.